speed, cost, and reliability. These are the three things that most organizations trying to use generative AI at scale struggle to balance. If you remember that classic triangle from university or college where you had to pick two things, either sleep, a social life, or good grades, in that same vein, a lot of organizations are having to choose either cost and reliability or reliability and speed, and you have to kind of compromise. With the brand new Claude prompt caching feature, this is the first light at the end of the tunnel to be able to accomplish all three. This brand new feature from Anthropic is still in beta, but it's already showing that there's a light at the end of the tunnel to allow all organizations to be able to have their AI cake and eat it too. I'm going to walk you through what prompt caching is, when to use it, and most importantly, how to actually leveraging it with a full code tutorial. Whether you're a developer, a product manager, or just someone that's Claude curious, this tutorial is going to give you an A to Z conceptually on how this works. And if you're not as technical, after the first half, I'll actually dive into Google Colab to actually walk through examples step by step on how to leverage this to its best ability. If you don't know who I am, my name is Mark, and I run my own AI automation agency called Prompt Advisors for the past 2 years. We help companies in every industry better understand where to use AI best in their workflows. Now, I've prepped some quick slides to go through all the nitty-gritty of this brand new feature to make sure you're fully informed on what it can and can't do. Let's dive right in. Now, first things first. What is prompt caching and why should you care? If you're an organization that just uses ChatGPT and Claude on the front end and you use no form of API on the back end or any form of automations behind the scenes, this probably isn't that useful for you. However, if you're an organization that's running thousands upon millions of records through LLMs every day, like Claude Haiku, Sonnet, or Opus, this has major implications for you and can save you a lot of time, money, and most importantly, speed. Now, the big picture is that instead of always having to take the same prompt with a huge context or a huge knowledge base and continually feed that back and forth into a prompt, or having to resort to using something like a SQL vector database or a general vector database to be able to store that data to then call it when it makes sense to, you can now have your cake and eat it too, just like I said, in the sense that you can have all that context and knowledge base essentially memorized and cached for a certain amount of time while you send multiple prompts that reference that are cheaper because you don't continually need to refeed that context over and over again. Now, like I said, it's primarily in beta. So you can only use it for two main LLMs right now, which is Claude 3.5 Sonnet and Claude 3 Haiku. If you use it properly and for the right use cases, it could potentially save you up to 90%. On average, from what we've seen already implementing this for some of our clients, it's saving around 40 to 60% depending on how long your prompts are. And I'll walk you through in a bit what might help you make the decision as to whether or not this is worth the trouble for you to even take a look at. In general though, the first thing that comes to mind is if you're in a business like a law firm or real estate, where you have monumental files that you wish your prompts would just memorize or understand, or you have multiple chain prompts that are based on the understanding of one major set of documents or examples, this is a silver lining for you, especially from a cost perspective. Just to visualize one of my last points here, typically you'd just have a huge context and a set of examples, especially if it's something more bespoke or complex. You typically might need 5 to 7 different examples to really give an LLM an understanding of what success or perfection looks like. And theoretically, you'd usually have a bunch of tasks where you theoretically have to re-inject that same context and example every single time to be able to yield the result you're looking for. Now, the main difference of using this kind of feature is that you are going to pay more upfront to be able to cache your context and examples than you would otherwise with a normal input token from a typical prompt. But the idea is if you have multiple prompts that rely on this context, then those will be cheaper in aggregate. And as you do the cost savings across all of those operations, daily, weekly, or however many times you run this for your organization, it's going to save you tons of money when you actually do the cumulative analysis. Now, when does it make the most sense for you to consider using prompt caching, and for what specific use cases? In general, there are 6 different use cases that Anthropic says this is great for. One is conversational agents, coding assistants, large document processing, detailed instructions, agentic search, and knowledge-based QA. Now, in this specific tutorial, I'm going to focus primarily on these. I'm going to leave the coding assistance and agentic search for another day, as that's hyper technical, and I want to keep this balanced so that even if you're non-technical, you can at least understand the implications this would have for your organization and your dev team. Now, there are two main details here that I really want to highlight. One of them is the fact that now you can give tons of examples, more than you have before, where maybe you only had 3 examples for the LLM to learn from. You could upgrade that to 7, 8, 15, theoretically, if you wanted to, and you don't have to worry about that context being forgotten over time or overridden somehow or having a lost in the middle issue. That's going to be mitigated greatly by this. And at least with our initial testing with our clients, we're noticing that the likelihood of having lost in the middle instructions in a prompt, which is basically when you have a very large prompt, that some of the instructions get overridden or are interpreted as noise over time and are ignored as you go from prompt to prompt, that this happens a lot less and it's a lot more focused, because in a way you're kind of partitioning your cache, which is your long-term memory, with your sub-instruction, which is kind of like what I want you to do now. So we're noticing that balance of large prompts and understanding and remembering things is a lot better naturally without needing some form of external resource like a vector database. Now, this is not to necessarily agree with all the sensationalized titles I'm seeing on YouTube right now, which is this is the death of RAG, which stands for Retrieval Augmented Generation, which is basically very complicated terms for you connect database that converts documents to numbers so a computer can understand. Then you have AI talk to numbers to actually speak to that knowledge in real time. While it's still a painful process, I don't see that going anywhere until this is at least out of beta, has much larger context windows, and the cost goes down even more to make it make sense where you actually don't need a vector database in the conversation. But until now, I still see that as part of your toolkit. But if you only have, let's say, a book or a series of 50 pages that you always resort to over and over, this might be a better alternative to using that typical infrastructure. Now let's move on to actually how it works. At a very high level, you have a user send a request. If that prompt is cached, which I'll show you the criteria for when it gets cached, then it's going to use that cache prompt, and then you can generate a response from that in addition to whatever query or question you want to ask. And then if not, then it's going to process the full prompt as it usually would at the rates it usually would charge, and then you can then cache that prompt for future use if you want to. When you think of cache, think of literally the cache you have in your browser. When you go on a web page, if you go on it for the very first time, it's going to take slightly longer to load. The second, third, fourth time, assuming you don't remove your history or cookies, the next time you load that page is going to be infinitely faster, which is the exact same idea here. The first time you send a prompt, obviously it's not going to be cached. Nothing's going to be cached about the context or examples. But the second, third time you actually process that, it's going to take way less. Now, one super important point is this, the 5-minute lifetime. So from the first time you actually choose to cache something, and you do so by basically saying a parameter that's a translation for cache this please. Once you do that, you have 5 minutes from the time you've done that to actually reuse that cache over and over again. Now, you don't have to send that initial prompt in 5 minutes, but assuming you stop sending requests that reference that cache information, after 5 minutes, it'll expire, and you'll have to redo that process again. So the idea here is that assuming you have some form of batch processing where you have one big context and you're constantly sending requests to maybe different users, different rows of information, that so long as you're doing that in some form of loop, and there's no timeout, you should be able to maintain that cache live, at least from our testing we've initially done. Now, there are a few big disclaimers that I want to make about when to actually use this and whether or not you actually should consider using it depending on the other conditions that I'm going to show you. Number one is you want to make sure that all the information you want to put in cache is actually static, meaning it's a set of instructions that doesn't need to be nuanced or changed very often. That's probably where it makes the most sense. So let's say you are a real estate firm and you always have XYZ way you write your listings, and you have these 6 or 7 types of listings that you have, and you have 5 examples of those listings. All of that is a really good example of a use case where this makes sense. Next, the minimum prompt length should be 1,024 tokens for Claude Sonnet and 2,048 for Haiku. And I want to hyper emphasize this because when I was figuring out how to actually write the code for this, I kept banging my head against the wall because I didn't understand this concept. So when you actually try to cache any information, it has to be a minimum of 1,024 tokens for Sonnet, meaning it's around 2-3 paragraphs worth of length. If you don't do this, it's just not going to work. You're going to look at your cache, and for some reason, the caching parameter is not going to be set, even if you have everything set up perfectly. Now, my hack to verifying whether or not my actual context is long enough is I use the old tokenizer tool from OpenAI to get it directionally accurate, to make sure that it's above 1024 tokens, plus or minus. If you end up using the code that I'm going to provide you today, there's a 99% chance that if you have any form of problems, it's going to be the fact that your underlying prompt is not long enough. So don't say I didn't warn you. All right, so the next one is the fact that you can't manually clear the cache for now. Again, this is in beta and was literally just released like a week ago, so it's natural that it's not all figured out. But as of right now, you do have to wait for that 5-minute expiration window to clear before your cache is technically expired or cleared. And the last thing, at least from our testing, doing cost-saving analysis for clients already over the weekend, it's really not worth doing this and like moving infrastructure if you have very grounded infrastructure, unless you're doing this on a scale of thousands, if not millions of records, where you can really realize that cost savings. We're not at the point yet where it's really worth it to abandon what you have to just jump on this, unless you're starting vanilla or you wanted an incentive to use Claude models and you didn't have one before. This is probably a good idea, especially as I expect this to land on Amazon Bedrock in the coming weeks or so. Now, in terms of pricing, I'll let you take a look on their website and do the math yourself as to whether or not it makes sense for you. In general, writing to the cache will be 25% more expensive than if you did it the standard way using standard input token pricing. Whereas to actually read that cache is going to be 90% cheaper than the same input based tokens that you would otherwise. So huge difference on the read and slight difference on the write. So I would say the cost benefit analysis here makes a lot of sense. Again, given all the criteria that I just went over. Now, if you're less technically inclined or code scares you, this is the part of the video where I'm actually going to jump into Google Colab to walk through everything. If you choose to hold on, I promise I won't make it that painful to look at. There's going to be some pretty diagrams above all my code to walk through what's actually happening there. But if it scares you, feel free to click off the video right now. All right, so this is the Google Colab that I put together. I tried to comment everything out and put headers where it makes sense to make it as readable as possible, as well as create some mermaid diagrams to just walk through what's happening in certain blocks of code. You'll find the link to it in the description below. It's going to be a Gumroad link where you can choose to give $0 for the link to the code, or if you wish to support the channel and myself to make my content better and better over time, I would super appreciate maybe a couple bucks for a coffee here and there. Either way, you can get it for free if you want to, and then you can follow along as I go through everything. All right, so first things first, we're going to install Anthropic here. And then we're just going to import Anthropic and time. All right, so while the rest of the code is running, we can start breaking down the first code block, what it's going to look like and what it's doing behind the scenes. So first we're going to import the Anthropic library. We're going to set up our API key. I'm going to have mine here that I'm going to delete after this tutorial, but you can just swap it with yours. And then we're going to initialize the Anthropic client, and then we're going to create a prompt pretty much. That's going to be our context that we're going to cache in memory. And again, I triple checked and made sure that it was actually eligible for prompt caching based on the length. And then we'll get some form of message that I've created through a function where it actually explains the metadata, whether or not that specific query was cached or not. It'll be abundantly clear once I show you, but in general, just think of a bunch of metadata that will say how many prompts have actually been cached or written to cache and how many have been read from cache. That will tell you whether or not it's working, because if your prompt writing has a number greater than 0, that means you've committed something to memory and it's working. At the same time, if you're reading from the cache and for some reason the number of tokens for reading is 0, you'll know they're not actually using the cache. Now, if we dive to the actual code here, we have our API key that we set here, and then we have our business context where I am going through pretty much everything about this fictitious company. If you want to take a look at the prompt more in depth, I put it in this Google Doc here. Nothing fancy, just a bunch of information about a company that does not exist. A lot of metrics about quarterly performance, and it's around 2-3 pages long. So I would say around 2.5 to 3 pages is typically the minimum for it to be eligible for this caching feature. So you can use that as a rule of thumb. If you want to be more particular like I do, I would take this, copy paste it, and I would use the tokenizer from OpenAI. Again, it won't be exact, it won't be perfect, but it's very directionally accurate. I'll just set it to 3.5 and 4, and then I'll paste it and it'll tell me around 1,178 tokens. I found that in general there's a plus or minus 50 token range. So if it's around 1,200, then either it's actually 1,250 or 1,150. So plus or minus that, you can use this to your advantage. Now that that's done, we pretty much just set up this portion, which is client.beta.prompt_caching.messages.create. So we need that method of prompt caching. You can set either, again, Claude Haiku or Claude Sonnet. In this case, I'm choosing Sonnet because it's a bit more sophisticated. And then here in the type text, in the actual text, I actually set the system prompt pretty much for this cache. This is going to be less important when it comes to doing this large context caching example, but when it comes to testing it out on the conversational portion, it's going to be hyper important that you give some love and care to this system prompt because it's going to guide whether or not it's going to be conversational. Unlike the Assistance API from OpenAI, I haven't found yet how to natively make it more conversational, where there's back and forth like you would any form of chatbot conversation. This portion here is a hyper important parameter called cache_control, and it's going to be set to ephemeral, which is fancy English for temporary, pretty much. This is going to tell the underlying prompt and the prompt infrastructure that we want to set the temporary memory, or in this case, the temporary time-sensitive cache, and this will basically inform it that we want to execute that. You'll see here in my next text portion here, I'm referencing the business context above. I like to do that for cleanliness, so I'm not just shoving a 18-line different text in here. Naturally, you can reference some form of file or anything else. And then our first test message will be, what are the key challenges Technovate Solutions is currently facing? When you output it, you'll see something like this, which is the prompt caching beta message. You'll have an ID for it. And one thing you could do is you can go to the very end and take a peek at the end. If you see cache creation input tokens equals something larger than 0, that means you've managed to successfully cache something to memory. Now I'm going to say it for the third or fourth time, but if this is 0, and you've set up everything exactly like I have, or you've used my code but put your own prompt in it, there's a 99% chance that it's just not long enough to be eligible to be cached. So when in doubt, triple, quadruple check that. Naturally here, we're not going to be reading any input tokens because we just committed to memory. And then it tells you input tokens and output tokens. So that's kind of like the default metadata we have. Now, as we go down, what I did is I took a stab at creating a poor man's calculator to try to tell me how much cost savings am I making by sending a additional prompt after I've initially cached it. It's going to be, again, directionally accurate. If you have a better version of it, then let me know in the comments below. I'm happy to be humbled that way, but I gave it my best shot initially. And pretty much I just walk through in this diagram how it's doing that calculation, which is if it's initial query, meaning it's the first time you're writing to the cache, it's going to naturally be more expensive. So I'm trying to price that in. Otherwise, we're going to just calculate the follow-up costs, which is, like we said, 90% cheaper than the average input tokens you'd spend otherwise. If we go down here, this is the main function that we have that is creating that extra metadata that we're going to have. So you can see here, I'm taking what we already have from Claude, then we're adding a few more components like the cache creation cost, the total cost overall, and any initial cost savings that we have. So again, directionally accurate, it's not going to be exact, but I was trying to do this for myself to give myself a bit of a cheat sheet as to what it might be. Now, when it comes to the follow-up queries, pretty much how it's going to work, assuming that it cached correctly, is if the cache is hit, it's going to say the cache is hit. It's going to have some metadata at the bottom of my output that I've written, again, from that function back above. If it's hit, then we're going to say yes. If it's using the cached context, then we're going to return a response. Otherwise, we can actually tell it to actually cache it if it hasn't already, but assuming we did it correctly, it should be perfectly fine. So then we have follow-up query 2, where I'm asking something about this company about European market share, and then assuming again, the cache is still there, it's not expired, then we'll use the cache context. Now, if I send this request after 6 minutes of the last cache initiation, then we will have to process it as normal. We'll have 0 cost savings whatsoever, but both will return a response. One will just be cheaper than the other. Now, for the very first question here, again, we're saying what are the key challenges that Technovate Solutions is currently facing? And then down here, we have my big response in bullet form. And I want to note that it's bullet form for a reason, because down below, when we get to the conversational version of this code, it's really important that we tell the system prompt to ideally not write in bullets and write more conversation-y short and long form so that we try to emulate that conversational experience. But for now, this is perfectly fine for just testing it. In our response metadata, like I said here, we're going to see that we're using this model. We have the input-output tokens. It's saying that we're using cache read tokens of 1305, the exact same amount as our original write. So I can tell that now I am benefiting from these cost savings. And then it'll say cache status. This is, again, something that I made. Cache hit. So I know, okay, cool, it's working. And then what is the estimated cost of this run? And I'm trying to make a directionally accurate cost estimate of how much this costed me. And again, this is helpful if you're trying to do this at scale to see, am I saving thousands of dollars, hundreds of dollars, or tens of dollars? Again, second query here, we're not going to spend too much time on it, but I say, what strategies should Technovate Solutions focus on to overcome its competition in the cloud management space? And we have some response here. And again, we see that the cache is hit, and we're reading 1305 tokens. Numero tres, we have another question, and we can just zip down. We'll see, again, we're hitting that cache. We're making some cost savings, and at the end of it, I'm just asked it to do some savings estimation from running the 3 different queries. So in this case, not too much. We're only ripping a couple queries or prompts at the API, but at a grand scale, this should be super helpful. This is a micro example of just large context. I didn't bother putting a huge book, but you could put pretty much anything you wanted so long as the underlying large language model can handle that context window, which I think for Sonnet is around 200,000 K context for now. So when we get to the next portion here, which is the multi-turn conversations, it's pretty much just like the Assistance API in terms of how they're framing it, where this is meant to be more back and forth conversation. I'm going to zoom in here, and I created a diagram in 2 parts. All right, so the way this is going to work is very similar to before, where we have importing libraries, we set up our API key, we define the prompt or business context. I created a function, like a send_query function, to make it a lot cleaner to send multiple responses versus having to send something like this over and over again every single time you want to send a brand new message. That's kind of like one fault, maybe a skill issue on my end, that I couldn't get the native API to give me like a cleaner way of sending those messages instead of using those breakpoints over and over again. So you'll see that query down below that I'll get to shortly. But in general, you'll have the send query function that I set up, which is just creating a Sparks Notes version of that API request. And then we're going to send 3 queries. It'll work the same way, where we're going to see, is it in the cache yet? Yes or no. If so, use the cache, and we're going to loop that until we're happy with it. In this case, I think I have 5 or 6 messages that I'm sending to the API. And you'll see here at the bottom, I just made this follow-up queries diagram. You can see if I zoom in here, you have query 2, query 3, query 4, 5, and 6. One's on steps to tackle challenges. One's on sufficiency, additional recommendations, we're asking it, impact on strategic goals, and implementation challenges. One thing I want to do very strategically is I want to make sure that my follow-up questions were not framed in a way where it would understand what the question is and what it's referring to without having answered me before. So if that seems a bit confusing, it seems confusing on delivery. To give an analogy, let's say I'm asking something vanilla to the API, like, what's the weather today? And it says, it's super rainy. Instead of me saying something that's easy for it to understand the context, like, what activities should I do on a rainy day? I just say, what are some activities I should do given this forecast, right? So if I'm saying this forecast, it doesn't know what it's referring to. So if it didn't know it was saying it was rainy before, I'll know from the response whether or not it's actually using the cache or not. So that was like my hack that was going back and forth for hours to understand how can I make sure it's actually using this context conversationally versus guessing or using my very well-worded questions to guess what I'm getting at. So if we go down here, we'll just jump ahead. We're using a different prompt here on a solar energy company. Again, fictitious. I just asked ChatGPT to generate it. And then I threw this into the tokenizer to make sure it was long enough. And then I created this send query function here that you can take a look at more in depth after this video if you choose to pick up this code. And basically what it does is very similar to the former metadata, but in this case, it just allows me to just send queries like this, send underscore query, and then it creates that breakpoint behind the scenes. And all I have to do is just ask the question. So can you summarize the key challenges that green energy is facing? So that's an easy vanilla question. The next one will be, which of these challenges do you think is the most urgent? So in that case, I have to make it understand or remember what the challenges it said were, so that when I check the answer, I know for a fact it's actually using what's in memory and what's been cached. So that's my little hack there. Next is, given that urgency, again, and making it very dependent on the prior response, what steps is the company taking to tackle this challenge? And the next one is, do you think these steps are sufficient, or should they take more measures? So if you just create these very dependent questions that are not obvious, if they were just taken mutually exclusively, it will help you make sure that it's working exactly as expected. So if you zoom back down, I'm going to send it a series of follow-up queries like I showed you before. And then what I found is that when it mentioned which steps it was taking, it was then taking that into consideration and answering each question in a way that made it very clear that it was actually taking the last cache response into account. Now you'll have to run this on your end and do some iteration to make sure it's working as expected. If you do see from run to run that for some reason cache status hit is not happening, then you might want to do some troubleshooting to make sure that one, your prompt is long enough, and two, that you're running it all within the same time period so that the cache is not expiring. Now, one thing I noticed as a flaw with this API is it has a series of timeouts. Even right before I record this tutorial, I was running the exact same code over again, and I got slightly different responses. I got 500 errors that were like timeouts. So I would recommend even doing delays between different queries, but I'm sure that in the next 1 month to 2 months, it's going to become a lot more mature, a lot more enterprise grade, and you'll be able to start reaping the rewards in terms of saving hundreds to possibly thousands of dollars per month, and possibly finally making generative AI make sense for your business. If you enjoyed this tutorial and love this type of content, please leave a like on the video, a comment down below, and sub to the channel. Appreciate you, and I'll see you in the next one.